This section will spend some time covering the network layout of our architecture, our environment, as well as some of the important features that Red Hat Enterprise version 5 will afford you as a systems or network engineer. So let's go ahead and open a shell. We'll launch our gedit utility. This is where we'll be storing our notes, and we'll just label the header Linux CBT EL5 edition, which focuses on Red Hat Enterprise v5.x. And with that said, we want to discuss the network layout so that you have a good sense for the boxes that are on our network. Similar to a classroom environment where the systems are likely to be connected to a shared switch or two, our environment is set up similarly, and we have a Visio JPEG that we can use to explore the configuration. Now, it hasn't changed much if you've been with us from previous versions of Linux CBT. It's virtually the same, and we've exported it here to a JPEG. Let's maximize this document, and by default JPEGs, PNGs, and other graphic document types are opened within a known desktop environment. So we're currently using Red Hat Enterprise 5, and these are the systems on the network, but first let's describe the network architecture. It's a flat subnet. There are two Cisco Catalyst 3550 switches. These are common switches that are used as the central points or connecting points or hubs. Those two Catalyst switches are interconnected by a GBIC that I'm currently hovering around in this area between the two switches. So it's a gigabit interface which serves as an uplink, downlink between the two switches. Both switches share the same VLAN information, which means they both belong to the same VTP domain, and they're using the Cisco protocol for virtual LANs as opposed to the standard 802 protocol. Now here are the various systems on the flat subnet 192.168.75.0. By the way, it's a /24. It's an internal class C, and the DNS is Linux CBT.internal. Now let's zoom in. We've got what is now a Debian box, this Debian 4X box, a PowerEdge 2600 series system that will convert to Red Hat Enterprise 5.x. So this will become a Red Hat box momentarily, and in fact, when we install it for the first time, it'll tell us that it has detected another version of Linux on the hard drive. So this is a PowerEdge 2600 system connected to one of the Catalyst switches at 100 base T. And its name when we set it up will be Linux CBT Serve 2 at the domain linuxcbt.internal. It'll run Red Hat Enterprise 5X, the currently available version, and its IP version 4 address, which currently isn't specified, will be 192.168.75 dot perhaps 195. We've also got another Red Hat Enterprise box named Linux CBT Serve 1. That's the system we're currently connected to, this Red Hat Enterprise 5 box. That's the system that we're using here. And in fact, from a separate shell, since we need to know how to use a shell, for those of you who intend to take the Red Hat Enterprise certification exams such as RHCT, RHCE, and so on, we'll show you all sorts of things to cover those objectives throughout our studies. So hostname, for example, tells you the name of the host, the fully qualified host name if possible, or the FQDN, and if not possible, at least the short name is returned, which is the leftmost part of the FQDN. So this is Linux CBT Serve 1, and sbin-if-config will tell us its IP address, 192.168.75.10. This is the system that we'll use as a portal to the remainder of the network. And it is running Red Hat Enterprise 5. Red Hat, like other Linux distributions, maintain numerous text files, in particular one which stores the version of Linux that is operating on the system. Usually in etc, if you search for *release*, you will find a file which covers the current release of the system. Here we see that for Red Hat, it's named Red Hat-release. So if we cat the contents of etc, Red Hat-release, it will tell us the version of Red Hat. It tells us that it's version 5 of the enterprise server. And the enterprise server comes in two flavors, advanced and normal. This is the normal or regular version, which supports up to 2 physical processors, or up to any number of logical processors emulated by those 2 physical processors. So we're running version 5 on this system. And let's navigate back to our JPEG to continue that discussion. Just maximize this again. And that's this particular system here, Red Hat Enterprise 5. Its name is Linux CBT Serve 1. We saw the FQDN. We know that it runs Red Hat Enterprise 5X because we've confirmed via the etc Red Hat-release file. Now in addition, on the other switch, we've got a couple SUSE Enterprise 10 boxes. One is named Linux CBT SUSE 1, indicated by the area that I'm hovering over here, and its IP address is 192.168.75.15. It is a VMware server. We'll be using it to install an instance of Red Hat Enterprise on VMware throughout our studies. It currently hosts a Debian instance, and it's known as Linux CBT Deb 2. In fact, we use this system primarily to cover Debian 4X. And we will create a VMware instance named Linux CBT Serve 3 with an IP address of 192.168.75.185 later on, just to show you how you would implement Red Hat Enterprise 5 on VMware. So this SUSE Enterprise 10 box, again, its IP is currently .15. It's got multiple IP addresses, but it is a VMware server and it runs SUSE Enterprise version 10. There is yet another SUSE Enterprise box on the network, connected to the same Catalyst switch, connected to the same VLAN as all of the internal systems, which means it wears a similar IP version 4 prefix of 192.168.75, with the only thing being different is the IP address to identify this box. Its IP address is 100, and this server is an all-purpose server. This is what you'd call a network infrastructure server. Network infrastructure servers tend to service DHCP, DNS, NIS, LDAP, and similar requests, but primarily DHCP and DNS. So this server's purpose is to be a network infrastructure server. It services, again, DHCP and DNS, among other things, but those are the key services. We reference it whenever setting up a system, especially when using static IPs, or if no static IP is assigned, an address will be assigned automatically to the calling client. So whether we're installing for the first time or booting a new system on the network, such as a Windows or Linux or Mac OS 10 box, the box will obtain an address from this particular system, which is on the internal network. Now we mentioned internal versus external. Again, this architecture hasn't changed in the years that we've been doing our training, plus or minus a few boxes, but it's the same flat subnet to make it easy to understand. What we like to do is have an internal network separate from a DMZ network, which is the region that I'm currently hovering in, and separated from the external internet. So we've got basically 3 networks. The internet, which is guarded by a Cisco 1811 router, which has a DMZ leg, which facilitates 2 systems that we'll discuss momentarily, and then an internal network, which is protected by that Cisco 1811 router. So on to the DMZ. Let's zoom back in and discuss the hosts that are there. In the DMZ, we maintain or keep a Windows 2003 server. It's an all-purpose server. It helps us to demonstrate various things such as PuTTY, perhaps using IE, Firefox, connecting to Squid on one of the internal systems for proxying services, so on and so forth. So to give you that DMZ perspective from Windows or Linux, we maintain both systems in the DMZ. A Windows 2003 system, and its IP address is on a totally different subnet of 10.10.10.0/28. So we've reduced the number of IP addresses that are available on this subnet, as there are only 2 physical systems that are connected. So the Windows 2003 system is 10.10.10.2. Its host name is Linux CBT 2K3. It shares the same suffix. Now, that's just something for you to note in the event that you don't know. Your DNS suffix, in our case, linuxcbt.internal, and in your case, perhaps in your corporate environment, whatever it is, yourcompany.internal or .org or .com or .net or internal.company.com, so on and so forth, can span multiple IPv4, IPv6 subnets. So the DNS suffix can be used internally and on the DMZ, as well as on other internal subnets if they apply. So in this particular case, that is what we have here. We have a differently numbered system in the Win2K3 box, but it shares the same DNS suffix, linuxcbt.internal, shared by the internal systems. Again, it's running Windows 2003. Now, in the DMZ we mentioned there's another Linux box, SUSE Enterprise 10. As you can see, we have an affinity to SUSE because it's easy to configure and it's pretty streamlined. So we enjoy that distribution. This system is named LinuxCBT SUSE 2. Its IP address is 10.10.10.3 with the same shared DNS suffix, and it's running SUSE Enterprise 10. Again, it's an all-purpose system. When we're on the internal network, for example, on the existing Red Hat Enterprise 5 box, we can launch SSH connections, FTP, and other types of connections to and from the SUSE Enterprise 10 box, and we may launch terminal services connections to and from systems in and out of the DMZ. So that's the purpose, that's the reason why we maintain these multiple networks. Internal, DMZ, Internet. Now, our Internet connection is DSL. The Cisco 1811 router takes care of it. We're also running IPv6 in addition to IPv4. The IPv6 configuration is straightforward. We covered it in LinuxCBT IPv6 edition. The Cisco router runs iOS 12.4, which supports IPv6 as well as IPv6 tunneling using 6-to-4. Basically, what we've done is selected a 6-to-4 IPv6 address. In other words, the IPv6 address is derived from the IP version 4 address assigned on our public interface. So this interface, which gets an address from our ISP that is used to create a unique IP version 6 prefix. That prefix is then extended into multiple subnets, one for the DMZ, one for the internal network. And by default, IPv6 automatically assigns addresses, so it's self-configuring. So long as you've configured the IP version 6 prefix using whatever technology you want, 6-to-4 or native, so long as you've configured it on your 1811 router or on your centralized device which supports IP version 6, internal, DMZ, and other connected hosts will self-configure. It's one of the beauties of version 6 of IP, whereas with IP version 4, we need to maintain a DHCP server or configure systems statically. So that gives you a sense as to the systems that are located on our network. Again, it's a flat internal subnet, 192.168.75. You'll hear us throughout our studies referencing 192.168.75 quite often with different IP addresses. We're going to make over or remodel this Debian 4X box into a Red Hat Enterprise version 5X box. We are using this Red Hat Enterprise 5 box with the .10 IP address. We said we'd make the new server .195. We have two SUSE Enterprise 10 boxes in our internal network that are general purpose servers. One in particular is a network infrastructure server. That's the LinuxCBT Media 1 box. We've got a DMZ. We have a Cisco 1811 router which supports connectivity to the internet, DMZ, internal network. And that's basically it. So for most of our products, this is the architecture that we use. So it's very straightforward, easy to follow. Now with that said, we should continue discussing some of the basic features of Red Hat Enterprise 5. So let's return to our text document, which is in the background, and continue discussing the features. So LinuxCBT EL5 edition is a successor, so it's the successor to LinuxCBT EL4 edition, which succeeds LinuxCBT EL or Classic edition, which we can also list as LinuxCBT EL3 edition. This is the update. Now you'll find that we cover many of the things we've covered in both Classic and EL4 editions, because over overall, the base technologies behind Linux, Unix have not changed. So using the shell, managing services have not changed. The version numbers may have changed, but the technologies have roughly remained the same, plus or minus some newly introduced technologies. So a lot of what we cover here has already been covered in EL4 as well as Classic, but of course we do so on the latest offering of Red Hat Enterprise, which is version 5. So again, for those of you who want to achieve or aspire towards Red Hat certification, you can use our product to help you as we hit the objectives listed on the Red Hat site for obtaining that level of competency. But of course, it always helps to use products such as ours, plus your own personal time to train using products like ours before approaching any examination, especially live hands-on examinations. Now, what are some of the features of Red Hat Enterprise version 5? Well, it features a 2.6x kernel. In particular, like Debian 4x, 2.6.18. This is a kernel that you'll find, and you can determine the kernel by executing the uname command, which is one of the hundreds, if not thousands, of commands you'll find on any stock Linux system. So from the shell, uname returns the version of, or the type of operating system. Uname-A returns a whole load of information. So use uname, and by the way, our typical convention for indicating commands is to specify them between single quotes. So whenever we indicate single quotes followed by a command or what appears to be a command, and you can tell because it's lowercase, as are most if not all Linux and Unix commands, then that's exactly how you should enter the command on your computer if you're following along or when you follow along. So uname-A returns OS information, in particular kernel information. And as you can see at the shell, this uname-A has returned, and let's just clear screen so that we see it with nothing else obstructing our view. It is the Linux operating system. The FQDN is returned. The version of the kernel, 2.6.18-8. Anything after the .18 means, or after the third number, means it's been patched by the distributor. And this kernel was shipped with, or distributed with, EL5, Enterprise Linux 5, Red Hat Enterprise Linux 5. It's an SMP-aware kernel, so if this system has multiple CPUs, logical and or physical, the kernel will pick it up, it'll detect it. Also, the time and date that the kernel was compiled is revealed. So January 26, Friday, 2007, it was compiled, and it is a kernel that will work with i686, i386 systems. So what does uname return? Although we have not yet formally begun our studies of Linux commands, but never hurts to delve right in, note uname-A returns the following useful info. 1. OS, which will be Linux for our intents and purposes. If you're on a Solaris system, then it'll be Solaris. And by the way, we do have a Solaris system on the network, which when we need to connect to, you'll see. We neglected to mention that or show that in the graphic. In addition, it returns the FQDN, fully qualified domain name, or FQDN. In our case, that's Linux CBT serve1.linux cbt.internal. The version of the kernel, in this case it's 2.6.18, so on and so forth, with 2.6 being the major release, .18 being the minor release, and anything after indicating that the kernel has been patched by the distributor. Also, the date and time the kernel was compiled. So timestamp, or date and time that the kernel was compiled. So you have a sense for how old or new your kernel is. And the kernel version, let's just note, that the 2 is equal to, or 2.6 is equal to major version, .18 is equal to minor version, and anything else after the minor version indicates that the kernel was patched by the distributor. So that's how you should read Linux kernels in the event that you're unfamiliar. 2.6 is the major version, as you may find with older systems, 2.4 being the major version, immediately followed by the minor version, subsequently followed by any changes made by the distributor of the kernel. And of course there are multiple distributors, numerous distributors, from Red Hat back to Novell with SUSE, Debian, Ubuntu, and the list goes on and on. There are many Linux distros, but the big distros include Red Hat, SUSE, Debian. Those are the 3 major distributions in use today. So again, features. We just spent some time just focusing on the kernel in particular, because it's important. You need to know what kernel you're running, as the kernel will impact how your operating system interacts with your hardware. So in other words, what hardware is supported and how it deals with that hardware. The kernel comes with certain built-in drivers. It also has the ability to load drivers or modules dynamically, and certain features, certain tweaks are available in newer versions of the kernel. So you need to know, especially if you have obscure or not so widely deployed hardware, you'll need to know which kernel you're running, if anything, to know whether or not the support that you need is there. For example, you may buy a custom third-party engineering or specialized application which requires a specific version of the Linux kernel for one reason or another. UNAME will return that information to you, and Red Hat Enterprise comes with what is considered to be the standard version of 2.6, and that's 18. Again, Debian ships with it, so does Red Hat, and 2.6 is also available with SUSE. So what are some of the other features? Well, Red Hat Enterprise supports multiple versions, including Basic, which supports 2 physical, or as they list it, they being Red Hat, socket CPUs, which means irrespective of the logical CPUs emulated or provided by the physical CPUs, this version of the kernel tied to Enterprise Linux 5, being the basic version that we're working with, will support 2 physical CPUs. So if you have, for example, a system with 4 physical CPUs, you'll need the advanced version of Red Hat Enterprise Linux. So the basic version supports 2 physical CPUs and a limited number of virtual sessions. But it does support multiple architectures, primarily within Intel, AMD, and IBM Z-Series and Power Series space. And perhaps we should separate these features out as A1 and A2, as to not confuse it with the next version that we're going to mention, which is the advanced version. So the basic version supports 2 physical CPUs, as well as up to 4 virtual guests. Red Hat Enterprise Linux includes virtualization technology provided by the Novell guys, or Novell. And that Xen virtualization within Red Hat Enterprise Linux Basic version 5 supports up to 4 virtual guests, which means you can install 4 instances of Red Hat Enterprise Linux within the basic environment. However, the advanced server, which succeeds previous advanced offerings, supports an unlimited number of CPUs as well as virtual guests. So advanced, and it's known as the advanced platform, by the way, versus the basic, and the basic is simply known as Red Hat Enterprise Linux Server, which is geared or targeted towards general purpose servers, not heavy duty servers such as application and database servers. The advanced platform, again, and we'll list as B1, supports unlimited physical CPUs, and of course this really doesn't make sense, as there are always limits imposed by the physics of semiconductors, and as a consequence, whatever the latest and greatest offered by the technology is the wall that you'll run into when using Red Hat Enterprise Linux Advanced Platform Edition. So as far as the software is concerned, the kernel that ships with Advanced Platform has no limits, or has no realistic or close limits. In other words, today's offerings, hardware offerings, do not exceed Red Hat Enterprise Linux capabilities. In addition, with respect to virtualization, which again this is a hot topic, supports unlimited virtual guests. Now again, by virtualization we mean virtualization included with Red Hat Enterprise Linux. We should note that. Let's just save this document first. We'll call it Linux CBT EL5 edition notes. Let's just note that the virtualization limits pertain to the virtualization technology included with Red Hat Enterprise Linux, not third-party software. And by third-party software, a good example would be VMware. So if you wanted to use, for example, the basic Red Hat Enterprise Linux coupled with VMware, you could support more virtual hosts or more virtual guests, providing you have enough hardware, which means enough memory, CPU, and fast enough disks. But when using the embedded technology, which is technology created and maintained by Novell, the limitations are set when using the enterprise version. When using the enterprise advanced platform, the only limitations are physical limitations, for which there are none today as far as the operating system is concerned. So basically you may be wondering, what does it take to run Red Hat Enterprise Linux? Any current system will do. Nothing in particular, just a current system is all that's required. And by current we mean the latest Intel Pentium, dual-core, quad-core, AMD, so on and so forth. The platforms, again, range within what we've just mentioned: AMD, Intel, and IBM Z series. Unlike Debian Linux, Red Hat Linux sticks to those platforms. So perhaps we should just note, as a third bullet, supports the following platforms. And this is because the folks at Red Hat have decided to zero in on or focus in on these particular platforms. Because again, with Debian Linux, it supports up to 11 platforms, including a wide variety such as Spark, Mainframe, MIPS, and all of the platforms supported by Red Hat Enterprise Linux, which is what makes Debian such an attractive offering. However, it requires an enormous amount of resources to maintain the builds for Debian to support so many platforms, and as a consequence it seems as if that's the main reason why Red Hat and other distributors like SUSE and Novell tend to focus on a limited number of systems. So the following platforms are supported: Intel, AMD, and by Intel we mean 32-bit of course, and 64, so 32/64 bits. Ditto for AMD, although you'll find that most of the AMD equipment that's out there nowadays is 64-bit base, and if that's the case, then you can install Red Hat Enterprise Linux on AMD 64 and make use of 64-bit technology. In addition, IBM, and in particular the Power and Z series, are commonly found, but it also supports S390. These are the platforms supported by Red Hat Enterprise Linux. Anything Intel, anything AMD, and the key IBM series, Power, Z, and S390. So these are your platforms. Basically summarize them as about 5 platforms, Intel, AMD, and some IBM platforms. But if you wanted to separate 32 from 64 bits, you could say that it supports, in addition to the 5 listed, 7 platforms. So we know the platforms, we know the 2 offerings, advanced as well as basic. We know the limitations with respect to physical CPUs and virtual guests. The memory limitations are really non-existent and only imposed by the limitations of your hardware. So note, memory limitation is based on hardware. So however much memory your hardware supports is what Red Hat Enterprise Linux will make available to your processes. Now, the common uses again of Red Hat Enterprise Linux is for your lower end servers such as file and print, web servers, and infrastructure servers. We should note that. But depending on your environment, the basic version may suffice for everything that you do. So common uses of the various versions of RHEL include, for RHEL, which is just the basic version, file and print, just meaning file and print services perhaps via Samba, including NFS, web server, infrastructure server. And by infrastructure we mean DHCP, DNS, proxy services, etc., lightweight services. Whereas for the advanced version, RHEL Advanced, we tend to get into the more resource-intensive applications such as application servers, such as Apache Tomcat, which is a servlet container, JBoss, WebLogic, WebSphere, etc. These are all major application servers that require as much resources as you can provide, as well as database servers, which include MySQL, which is included, PostgreSQL, Oracle, Ingress, etc. So you'll want to use RHEL Advanced version for application and database servers. However, if you intend to do some clustering, that's another usage. So use it for clustering, perhaps using the Red Hat Global File System technology, which allows you to make file systems redundant. So these are some of the deployments that you're likely to use the advanced version of Enterprise Linux for versus the basic version. The basic version, again, web servers, file and print servers, and depending on your file and print, if you need redundancy, then look at the advanced version as the technology is included. So that said, we've spent a good time, a little over half an hour, discussing the topology, network topology, as well as the features and what we'll be focusing on. Again, we're going to spend about 40 hours discussing the latest offering of Red Hat Enterprise Linux to get you up to speed, and that's what we'll continue to do.